Welcome to Computer Architecture Lab. We're going to look at Lab 2 today, and I'm going to try to help you get started. The topic is finding the biggest number, and problem 2.1 is to have an array of numbers. The list begins at the address located in register A0, which means you have to make A0 point to the beginning of the array. The length is given at A1, and you have to find the largest number and enter it into register V0, and also display it on your screen. Okay. Also, we have, well, maybe we'll talk about another video about the calculator. That's part 2. Okay, so let's go straight to it. And here is our Mars simulator. And we need to make an array. So why are we down here? Let's go all the way to the top. Let's do file, new. And let's say dot data. Data is going to be the way we declare an array. And we'll call our array list. You called it in the question. And we're going to put some numbers. Now, are these numbers supposed to be words length or byte length? Let's check. Each data is sized in bytes. In other words, it's a list of bytes. Is sized in bytes. Let's be okay. And assume that it is signed. So let's make our array according to those instructions. And we're going to say, instead of dot word, we're going to say dot byte. And we're going to say, for example, negative 13. And we could say like 67. And we could say like negative 9 and 0 and 48 and 100 and 90. Okay. And our goal is to find the largest value. Isn't that right? Find the biggest number, the largest value. Okay. So, well, that's the Hebrew one. So, we've got our array. And now we're going to start our actual program text. And let's get the address of the array. You have to put it in $A0. So that's going to be our pointer to the array. And it's going to point to an array which is named list. So now we've got our pointer. And now let's say we want to get the first number. So we have used before load word, but that is for loading a word length data. This is a byte length data, so we're going to use a different command, load byte. And we're going to put it into, for example, $T0. And what byte are we going to take? Let's take the first one, 0, of our array, which is pointed to by $A0. Now, we want to take another array, another an element of the array, because we have to compare it. Now, let's say like this, that T0, this is the best algorithm to solve this problem. I'll tell you now. A lot of people will say, oh, I'll take 0, and I'll see if a number is larger than what I've got, which is 0. Basically, that's wrong, because we could have negative numbers, like I pointed out by putting negative numbers here. So what we've got to do is take the first number that we hit and say, well, he is the biggest number until I'm proven otherwise. In other words, I'm going to assume that negative 13 is the largest number in the array. If I get proved otherwise, in other words, I find a number that's larger, then I'm going to switch. So T0 is going to store my biggest. And every new number that I want to compare the biggest to is going to be in T1. So let's do LB $T1. Now we'd like to write, I guess we could write 1 here. $A0. That would get us the next one. But instead of doing that, because that's only going to get us, then the next one I can write 2, and I want to make this into a loop. So I don't want to write hard-coded in a 1 here, and then a 2, and then a 3. So instead what I'm going to do is I'm going to do pointer arithmetic, and I'm going to say add I, because I'm going to put an immediate, $A0, $A0, 1. And that means that our pointer, which is pointing here, is now pointing here. But I can still, so therefore, since the pointer is pointing here, I can still use offset 0 to get the next one. Now I wrote 1, not 4, because it's a byte array. Each byte is the next place in memory. So I go by 1, not by 4. Okay, so now I've got the next element. And I need to compare them. Now the only thing we have to compare is SLT or SLTI. But let's do SLT because we have 2 registers. So doesn't really matter what we write. SLT, we're going to put it into, let's say, variable, just to separate our T's from other purposes. Let's use an S. $S0. And if S0, no, if $T0 is less than $T1, well, what does that mean? Should I just write something and then I think about it? I write that. If it's less than this, well, I want the biggest one. So if T0 is supposed to store the biggest one, it's wrong because this one's bigger. If it's less than this, so if this is 1, I got a problem. So I'm going to, if it's not equal to, let's say it's not 1. If it's 0, then if everything's good, then I just go again. So I'm going to write, if it's good, branch equal, well, I happen to be able to check if it's good, 0. If it's equal to 0, if what is equal to 0? The thing that we got, S0. If it's equal to 0, that means it's not less. That means this one is not less, so that means everything is good. I don't have to do anything. Then I'm going to branch to where? To loop start. And now I got to make a label called loop start. And where am I going to put that label? Well, obviously not here. I don't want to get the beginning of the array again. And also not here because that's where I assigned the biggest the first time. I'm going to do it right here where I increment. Loop start. And that will start me off incrementing to the next one and getting another one, etc., etc. And I'll keep going. Now, I didn't write whatever you should write here, and however you're going to end the program, I didn't write. By the way, how are we going to end the program? Let's look at the question. Is it here? No. Is it here? Yeah. The length is given in A1. Okay, so that's a key piece of information. So now we're going to do that. We're going to have to say, all I have to do is say like this, LI $A1, and I got to put the length. Now I want you to write the right length. In other words, you just count it, and that's the number. Don't write any other number. Don't make it one less or more. It's confusing. 1, 2, 3, 4, 5, 6, 7. 7. Now, obviously, I'm going to have to check sometime this A7. I'm going to have a counter. It counts up to that. I leave that to you guys. But I did the hard part, which is showing you how to use the SLT and showing you that you must remember to use LB and not LW, and how you take the first one just one time. And then each time you compare it to the next one that you have in your array. You have to figure out how to count or how to you can reduce this. You have a variety of ways of solving it. Okay, that should get you started for lab 2.1. I'll stop here.